Good afternoon, dear children. As informed earlier, we can do the problems for the lesson laws of motion. Okay, all of you having the questions that I have given. Okay, take the questions. We can do one by one. Okay, the first question is a body of mass 10 kg moving with a velocity of 20 meter per second along a straight line collides with another body of mass 8 kg moving in the direction with a velocity of 5 meter per second. Then after collision, if the velocity of the former is reduced to 16 meter per second, then calculate the final velocity of the latter. Okay, that is actually the question. A body of mass 10 kg moving with a velocity of 20 meter per second, and this can be taken as the first body. So its mass is taken as m1 is equal to 10 kg and it moves with a velocity that is taken as u1, that is equal to 20 meter per second. Okay, and it moves along a straight line, then collides with another body of mass 8 kg. So m2 can be written as 8 kg and it moves with a velocity of 5 meter per second. Okay, this is the case actually before collision. M1 is equal to 10 kg and it moves with a velocity 20 meter per second, and the M2 equal to 8 kg and it moves with a velocity of 5 meter per second. And after collision, if the velocity of the former is reduced to 16 meter per second, okay, that is the first body that moves with a velocity of 20 meter per second before collision. Then after collision, it reduces to 16 meter per second, that is v1 equal to 16 meter per second. Then we have to find the final velocity of the second body, that is the latter. v2 we have to find. Listen to it. Here the final velocity of the second body we have to find. Then how we can find this velocity v2? Here we are applying the law of conservation of momentum. Okay, by law of conservation of momentum, total momentum after collision, total momentum after collision is equal to total momentum before collision. This is actually law of conservation of momentum. Otherwise, we can say the total momentum remains conserved. That means actually total momentum of two bodies after collision is equal to the total momentum of two bodies before collision. Okay, so we can write the sum of momenta of two bodies after collision, that is actually m1 v1 plus m2 v2, that is equal to m1 u1 plus m2 u2. Okay, actually this is the total momentum after collision and this is the total momentum of two bodies before collision. Then we can substitute. M1 is actually 10 into V1 is actually 20 plus M2 is actually 8 and V2 we have to find, that is equal to M1 U1, again 10 into what is U1 actually, sorry, here actually M1 V1, M1 is actually 10, then V1 is actually 16, sorry, V1 is actually 16, then M2 is actually 8 kg, then V2 we have to find, then M1 again is 10, then U1 is actually 20 plus M2 is again 8 into U2 is actually 5. Okay, here it is 10 into 16 actually 160 plus 8 V2, that is equal to 200 plus 40. Listen to it. So 8 V2 is actually 80, then V2 is equal to 80 divided by 8, actually it is 10 meter per second. Okay, and this is the velocity of the second body after collision. Actually it is 10 meter per second. 10 meter per second. Okay, here a body of mass 10 kg, that is M1 is taken as 10 kg, which moves with a velocity of 20 meter per second, that is U equal to 20 meter per second, and it collides with another body of mass M2 equal to what, 8 kg, and it moves with the velocity 5 meter per second in the same direction. Okay, then after collision, the velocity of the first body reduces to 16 meter per second. Then we have to find the velocity of the second object after collision. Here we are applying law of conservation of momentum. So according to law of conservation of momentum, total momentum after collision is equal to total momentum before collision. So we can write m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Then substitute for m1 as 10, then v1 as actually v1 is 16 plus m2 is 8 kg and v2 we have to find. Then m1 is again 10, then u1 is actually 20 plus m2 is 8 and u2 is 5. Then simplifying this, we will get the velocity of the second body as 10 meter per second. Okay. Okay, the second question is, a bullet of mass 10 gram is fired from a gun of mass 8 kg with a velocity of 160 meter per second. The velocity of 160 meter per second. Find the velocity of recoil of gun. Okay, so we have to find the recoil velocity of the gun. Here the bullet of mass 10 gram. So it is m is equal to actually 10 gram. Then we have to convert this gram into kilogram. How we can convert this gram into kilogram? Okay, divided by 1000. So we got 0.01 actually kilogram. That is the mass of the bullet. Okay, it is fired from a mass of from a gun of mass 8 kg. So mass of the gun is actually 8 kg. Okay, and the bullet that moves with a velocity of small v, that is equal to 160 meter per second. 160 meter per second. We have to find the recoil velocity of the gun. Here also we are applying law of conservation of momentum. Okay, that is the total momentum before firing is equal to the total momentum after firing. Momentum before firing is equal to momentum before firing is equal to momentum after firing. Okay, this is actually law of conservation of momentum. Okay, you know, before firing both the bullet and gun are at rest, so its total momentum is 0. Then the momentum of bullet is actually mv and that of gun is actually m into v. We have to find this capital V, that is the recoil velocity, the velocity with which the gun moves backward, that is the recoil velocity. That is actually is equal to V is equal to actually minus mv divided by m. This is actually the expression for what? Recoil velocity. Okay, then we can substitute for m, actually it is 0.01 and its velocity is 160 and divided by 8. Okay, the mass of the gun is actually 8 kg. Okay, by simplifying this we will get 0.2 meter per second. This is minus, this is the recoil velocity of gun. Actually this is the recoil velocity of gun. Here we have a bullet that of mass 10 gram. Okay, in kilogram actually it is 0.01 kilogram and it moves with a velocity 160 meter per second and the gun mass of gun is given as 8 kg. Here we have to find the recoil velocity of the gun. For that we are applying the law of conservation of momentum. That is momentum before firing is equal to momentum after firing. Then before firing both the bullet and gun are at rest, so its total momentum is 0. Then after momentum, after firing, the total momentum is mv plus mv. From this the recoil velocity v is equal to minus mv by m. Then substituting these values, we will get the value of recoil velocity as minus 0.2 meter per second. Next, the third question is, a cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing the speed. The coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip or skip while taking the turn? That thing we have to find. Here a cyclist is speeding at 18 km per hour on a circular level road, takes a sharp turn. Okay, that is the velocity of the cyclist. Velocity of the cyclist is given as what? Given as 18 km per hour. Okay, here we have to convert this 18 km per hour into meter per second. For that we have to multiply it by 5 by 18. So 18 into 5 by 18. Actually, it is 5 meter per second. Okay, the velocity of the cyclist is actually 5 meter per second. And without reducing the speed, he takes a circular turn, sharp circular turn of radius r equal to 3 meter. Okay, the coefficient of friction, static friction between the tires and the road is given. That is, mu is given as 0.1. Mu is given as actually 0.1. We have to find, will the cyclist slip while taking the turn? That thing we have to find. Okay, you know the maximum speed limit on a circular level road. That is, what is the maximum speed limit on a circular level road? You know, root of mu s r g. Okay, V max equal to square root of mu s r g. Suppose if the speed of the cyclist exceed this value, he will skid or slip. Let's see what is the maximum speed limit. That is equal to square root of mu s is actually 0.1 and the radius is 3 meter. Then g is actually acceleration due to gravity. It can be taken as, either we can take 9.8 meter per second square, or approximately it is 10 meter per second square. Okay, for simplicity we are taking g as 10 meter per second. Okay, by simplifying this, we will get to 1.732 meter per second. Actually, this much only the speed, the maximum speed with which the cyclist can take that circular level road without skidding. Okay, but actual, what is actual speed of the cyclist? Actual velocity of the cyclist, actually it is 5 meter per second. It is actually the velocity of the cyclist is greater than this speed limit V max. Okay, so what will happen? The cyclist will slip while taking the turn, or skid while taking the turn, isn't it? Here actually the velocity of the cyclist is 5 meter per second, and while taking the circular level road, the maximum speed limit is 1.732 meter per second. Okay, so here the velocity of the cyclist is very much greater than the speed limit, so he will skid, isn't it? Here actually a cyclist is speeding at 18 km per hour on a circular level road, takes a sharp circular turn of radius 3 meter without reducing the speed. So actually velocity of the cyclist is 18 km per hour. So we have to convert it into meter per second. For that we are multiplying by 5 by 18. So we got 5 meter per second. And here the radius of the circular path is 3 meter per second, and the static friction between the road and the tires is actually 0.1, and the acceleration due to gravity is taken as 10 meter per second square. Then we know the equation for the maximum speed with which a vehicle can negotiate a circular level road is actually V max equal to the square root of mu s r g. Then substitute these values, we got the maximum speed limit as 1.732 meter per second, which is actually less than the velocity of the cyclist. So the cyclist will slip from the circular path. Okay, all of you got it? Okay, next the fourth question is, a car of mass 1000 kg moving with a speed of 30 meter per second collides with the back of a stationary lorry of mass 9000 kg. Calculate the speed of the vehicles immediately after the collision if they remain joined together. Okay, that is actually the question. Here a car of mass. Okay, so for the car actually, first we can consider the car. For the car, its mass is actually M1 is equal to what? 1000 kg. And it moves with a speed of 30 meter per second. That is, U1 is taken as 30 meter per second. And this car collides the back of a stationary lorry of mass what? Stationary lorry of mass 9000 kg. So for the lorry, its mass M2 is actually 9000 kg. Okay, actually it remains stationary, so its velocity before collision, its velocity is actually U2 is equal to 0 meter per second, isn't it? Then we have to find the speed of vehicles immediately after collision. They remain joined together. So the speed remains the same. The speed of the car is equal to the speed of what the lorry after collision, because they remain joined together. So actually here V1 is taken as V. Here also V2 is taken as V. Okay, because both the car and lorry join together, so they move with the same velocity after collision. Okay, here also we can apply the conservation of momentum. Here also we can apply the conservation of momentum, that is momentum before collision is equal to momentum after collision. Momentum before collision is equal to momentum after collision, that is momentum before collision is actually m1u1 plus m2u2 is equal to. Okay, then after collision, the car and lorry joined at most the same velocity. So we can write m1 plus m2 into v. Okay, this v we have to find. Okay, velocity of the car and lorry. I think we have to find. Then we can substitute. M1 is actually 1000 kg, 1000 into U1 is actually 30 plus M2 is actually 9000. 9000, its velocity is 0, that is equal to m1 plus m2. 9000 plus 1000 into v. Okay, here it is actually this turns 0, then 3000, 30,000, that is equal to 10,000. Okay, 10,000 v. Okay, then we have to find 30,000 divided by 10,000. Actually it is 3 meter per second. So the velocity of the car and lorry joint, okay, joint velocity actually it is 3 meter per second. Isn't it? Here a car of mass 1000 kg, that is m1 is 1000 kg, it moves with a velocity of 30 meter per second. Then actually it collides with a stationary lorry. Okay, the mass of the lorry is 9000 kg and it is stationary, so its velocity is 0 meter per second. Then after collision these two are joined and moves with the same velocity. So v1 is taken as v and here also v2 is taken as v. Then we have to find the velocity v. Okay, then here also we are applying law of conservation of momentum, that is total momentum before collision is equal to total momentum after collision. Then before collision the total momentum is m1u1 plus m2u2, that is equal to after collision the car and lorry joined, so m1 plus m2 into v. Okay, then substitute all these values, we will get the velocity v as 3 meter per second. Next, the fifth question is the coefficient of friction between the ground and the wheels of a car moving on a horizontal road is 0.5. If the car starts from rest, what is the minimum distance in which it can acquire a speed of 70 km per hour? Take the value of g is equal to 10 meter per second square. Okay, here we have to find the minimum distance traveled by the car to acquire a speed of what, 72 km per hour. Okay, here actually given the coefficient of friction between the ground and the wheels of the car, that is mu is given as 0.5. Okay, and here the car starts from rest, so its initial velocity u equal to 0. Okay, u equal to 0. Then the final velocity v is given as 72 km per hour. Okay, here also we have to convert this kilometer per hour into meter per second. For that we are multiplying by 5 by 18. So we got 20 meter per second. So in order to attain the velocity 20 meter per second, how much distance this car have to travel? How much distance this car has to travel? That is actually we have to find. Okay, for that we are, you know the relation, the coefficient of friction is equal to F divided by R. That is, you know. Okay, the coefficient of friction is the ratio of frictional force to normal reaction. Okay, coefficient of friction is the ratio of frictional force to normal reaction. Actually, the frictional force is actually, it is m into A, and the normal reaction is equal to the weight, that is actually m into G. This mm cancels and mu is, we got A by G, and we have to find A. Then only we can calculate what the distance. By knowing the acceleration only we can calculate the distance s. Okay, so A is equal to actually mu into G. Okay, then what is mu actually? 0.5. Okay, 0.5 into G is actually taken as 10. So it is 5 meter per second square. This is actually the acceleration, 5 meter per second square. 5 meter per second square is actually the acceleration. Okay, next we have to find the distance. We can consider this relation v square minus u square equal to 2as. Okay, this is the equation for finding the distance s. Okay, here here a is here. Okay, so we should know the value of a, then only we can substitute here. Okay, that is why we first calculate the value of acceleration. Okay, then we can substitute b as actually it is 20 square, u square is actually 0, that is 0 square is equal to 2 into a is given 5, then we have to find s. Okay, so s is equal to actually 400 divided by 10, so it is actually 40 meter. Okay, here it is actually 40 meter. The minimum distance in which the car can take the speed of 20 meter per second is actually 40 meter. Listen to it here. And in the question, the coefficient of friction between the ground and the wheels of a car moving on the horizontal road is 0.5. That is mu is taken as 0.5. And if the car stands from rest, so its initial velocity u equal to 0, and it acquires a speed of 72 km per hour. So 72, we have to convert this kilometer per hour into meter per second. So 72 into 5 by 18, actually it is 20 meter per second. The next, the coefficient of friction is equal to F by R. Then instead of F, we can write MA. Then instead of R, we can write weight mg. Then mm cancels and the mu equal to A by G. From this A equal to mu G. Then we can substitute mu as 0.5 G as 10. So we got the acceleration 5 meter per second square. Next, we have to calculate the minimum distance to acquire a speed of 20 meter per second or 72 kilometer per hour. For that, we are considering the equation v square minus u square equal to 2as. Then substitute v square as 20 square, then 0 square equal to 2 into a is 5 into s. From this, s equal to 400 by 10. Actually, it is 40 meter. Okay, children, that is the end of today's class. Thank you all.